Hi, it's Robbie McQueen here from Wolf EMS. Today we're looking at Luke's R33 Skyline. We're going to be looking at the fuel system and how it incorporates into the Wolf system. What we've got is two 044 pumps running to two fuel lines to the engine. We're doing this because we're on E85. Now, what we do that's a little bit different than most is we've got two pressure sensors and two one-way valves, right? And the Wolf actually monitors them. We've also got a flex fuel sensor so that we can actually monitor the temperature of the fuel because E85 is very temperature compensated. We come up to the engine bay and we've actually got two fuel lines in and one fuel line out going through a pressure read. What we do is we actually stage the pumps. We watch the pressure. If the pressure drops at any stage, we drop the boost. We bring one pump on to about 12 pound of boost, then we bring the second pump on. We don't want to over pressurize the pressure rig either. We're actually monitoring both of the pumps. As I said, if one pump happens to drop out, if a failure of a pump or wiring failure, then we'll actually drop the boost. This thing runs a constant of around about the 30 odd pound of boost, so you don't want to run out of fuel at that kind of boost. We're running two fuel lines up from the back of the car, both independent pumps with one-way valves on it. So if you pump in through this side, it'll go through the rail into this fuel line. Because there's a one-way valve at the back of the car, it can't flow back, has to come back out through the pressure rig. We run two pumps independently turning them on at different pressures so we don't over stress out the pressure rig. Okay, what we've got here is a data log that's been played from this engine. You can see we've got RPM, load, throttle, boost. This is pump 1 and this is pump 2. Now you'll notice that as I played the data log, we're at 1700 RPM, we've got 38 PSI fuel pressure. And as we start to increase on boost, you'll notice both pumps come on. We're monitoring 60 PSI of pressure in both pumps. That comes on over 12 PSI of boost, and we're back down to an idle, and we've got residual fuel pressure left in it. So what we're sort of saying there is that we can monitor the fuel pressure in the system. We can monitor that if we don't see that kind of pressure through a power run, through a drag run, that we can actually reduce Luke's boost and save the engine for him and put up engine check lights.